Gary Bonkowski, interview question dated November 7, 2022. I'll read the question. Inbound flow question. You're in charge of the department that receives the product into the building and stows it into the bin where it is accessible by the department. You have two options on how to receive and stow the product. In the first scenario, you receive the product at 250 units per labor hour and stow it at 100 units per labor hour. You must receive it and stow it for the unit to count for production. This process results in 1% of the units being stowed incorrectly. You can find and fix these errors at a rate of 20 units per hour with what you believe is almost 100% accuracy. Scenario 2, you receive and stow the product in one step versus two, so this is an integrative process. The rate for this process is 80 units per labor hours for receive and stow. This process results in an increased 1.5% defect rate, units being stowed incorrectly. You can find and fix these errors at a rate of 20 units per hour with what you believe is almost 100% accuracy. Which option would you select to process today's units and why? I chose option 2, and I don't think it matters whether they're 100,000 units or 1 million. The equation is still going to be less efficient during option 1 because of the requirement to receive and stow as separate and individual tasks. Anytime you can reduce touches to optimize a process, a favorable outcome is produced, as there are countless manufacturing examples and best practice formulas under the Lean and Six Sigma methodology that support fewer touches. Inventory handling costs fall under the compound effect at scale. So it's not just about the one pallet that costs $1 to $2 for each additional touch. It's the annual expense of 2 to 5% of the total value of your inventory. For smaller operations, this is less impactful, but for warehouses operating in the Goldilocks zone, that's 50 to 100,000 square feet, this would certainly apply. And for the behemoth fulfillment centers at 1 million square feet plus, I can assure you that the methodology employed in scenario 2 will be required by senior staff. Question number 2, does your answer change if you are told you must fully process 100,000 units today? If yes, why? No, the answer doesn't change. We'll still receive and stow more while simultaneously improving quality, and here's how. Option 1 with 10 associates. 3 to receive and 7 to stow, so I've got to break up the functions because it's a split process. To stow would produce 700 UPH. That 3 to receive is fairly common. I mean, for any ship dock receive operation, you've got to have 3 minimum to receive. So that's fairly common. That would leave me 7 to stow, which is going to give me at 100 UPH per associate, 700 UPH with an error rate of 1% and no dedicated QA/QC associate. Stow rate is now constrained at 700 UPH, and I still have a 1% defect rate to work out, and so that's not an optimized solution. Option 2, or scenario 2 with 10 associates, would now free up, because it's an integrative and consolidated approach, 9 to receive and stow in an integrated process will allow for 1 to be assigned as a QA/QC. So while still increasing UPH, so 9 times 80, because it's 80 units per labor hours for option number 2, gives me 720 UPH. That's an increased UPH of 20 units per hour, 20 units per hour for the 9 associates, while also or simultaneously improving the quality of the receiving and stowing, as we'll now have a dedicated QA/QC associate. So the thing to focus on is that Lean and Six Sigma is still very relevant in today's logistics, e-commerce, and even in manufacturing. The methodology categorizes 8 types of waste: defects, overproduction, waiting, non-utilized talent, transportation, inventory, extra motion, and extra processing. So we've got at least 4 or 5 covered here in this scenario, and I think that's what is probably the overarching message here. So we can reduce defects, we can reduce waiting, we're optimizing talent, inventory motion is reduced, and extra processing is reduced.